I'm Georgie from the Barossa Improved Grazing Group. Today we're here to talk about soil pits. This site is located at Graham Keynes' property near Keyneton. The weather station behind me is part of the big weather station network. It measures soil moisture, temperature, rainfall, wind direction and wind speed. Today we're here with David Woodard from Rural Solutions and Rebecca Tonkin from Adelaide Mount Lofty Ranges Natural Resources Management Board. They're going to take us through the soil pit to look at the constraints and also the improvements that can be made for the soil.
So this is the Keynes soil pit out at Keyneton, and again you can actually see from about 70-80 centimetres deep, you can actually see the parent material that this is formed in, and it's some highly weathered rock there. Reasonably, probably a meta sandstone we'd call that, and again part of the Keyneton group of rocks, and the soil's formed above that with a clay layer and then a topsoil layer above that through there. Some similarities to Evans's, but you know, a bit different too, I suppose. Not as rocky through the profile in this case.
Okay, we're on the Keynes property. We're in the sort of Keyneton district, as you can see from the landscape. It was hilly, undulating. We're still in the hill country, so you suspect quite a variation in soils. We're on the northern slope. Particularly when looking at the soil pits, the first thing is to look at the layers and the colours. They tell a bit of a story. The very top, high in organic matter, is slightly darker. The same soil texture is in that 0 to 12 centimetres, and slightly lighter colour than this due to the less organic matter. And then we've got the third layer is this white layer sitting above the clay, the orange clay. So that tells us it's has a temporary waterlogging and is sort of bleached by the water that sits there for, could be a few weeks, could be a few months, depending on how wet it is each year. And then the sort of orangey mottled sort of clay, just the colour tells you that it's probably quite a tight sort of clay. It's not free draining, it's quite tight structure, and although you can see how the roots go down between the cracks and can sort of extract moisture through that profile. Colours, the variation in colours due to the clay type tells you that it is waterlogging. Then the bottom layer is the weathered sandstone feature. You can see there sort of plates of stone that's sort of breaking down into soil eventually. Is the bottom layer. The darker layer tells you it's got quite a bit of organic matter, a lot of root structure. The roots and the plants tell you a few things, that the roots are quite small when you get down to this 50 to 60 centimetres and start to disappear only between the layers of clay in that lower layer. In examining your soils for barriers, we've already can see one with that bleached layer, and the orangey colour tells you possibly, well, the waterlogging is due to this quite a tight clay, although the roots can get through it to a certain extent. It is providing a bit of a barrier to root growth in that upper topsoil. The things that so we've got a bit of an organic layer there, a sort of a bit of a compacted, and that's due to just the soil texture, a little bit more clay in it, and then this quite white third layer above the sort of clay types. Things we can we look at, and obviously in looking at examining the soil, we talk about the percentage of clay, and we're mainly interested in that from its erosion potential, water holding capacity, is how much clay is in the profile, is how much water it can hold. So we wet up a piece of soil, each layer, wet it up and see how far we can ribbon it out. And the more you can ribbon it, the more clay in it. So this is we've got about 1.5 centimetres, 2 centimetres, so it's quite a sandy loam, and you can feel the sand and you can hear the sand. So it's quite a typical texture for this type of area, and from where the rock has come from. So we sort of examine the soil texture as we've done then. So so that provides us the sandy loam, reasonably moisture holding capacity, and also lets water in quite well. It also means that sort of 20% clay means it can hold reasonable amount of nutrients because of the clay content. The next thing we can look at in the paddock is the pH, and we take a crumb of soil from each layer, and we use a proprietary kit for home use, quite available, and we use the indicator solution on each soil. So I put a piece of soil from each layer in this unit here, and then we put the colour on to bring out the colour a bit better. We've actually discussed with the landholder that they limed this a few years ago. So we've got the topsoil, the sort of sub-topsoil, so 5 to 12 centimetres, the E-horizon, that white layer, and then the clays, top of the clay. So the liming, we can see, has had an effect on the pH, so the pH of about 5.5, 6, and then we're getting more yellow with the acidity in that 4.5, 5 range, and the subsurface layers are back down to the 6. The next thing to do would be to do a soil test to work out, this is telling us it's quite low, is to find out how low it is and how much lime you might need to apply to correct it. So we turn to the soil chemistry, and from our tests we've taken around the pit, we've got these sort of sub-layer and this layer to be quite acidic, and also with an aluminium toxicity rating which is starting to be of a concern. Not as high, it's only on the margin. So the first bit of liming probably hasn't gone all that deep, and that would be due to the poor couple of seasons we've had with rainfall. Hasn't quite washed it lower, and also the starting point might have been quite a lot lower than what it is now. So so the things on the chemistry, our chemistry tests confirm that soil acidity is an issue here, and so we need to lime it. Other chemistry suggests that it's the organic carbon. We can see in that top matter, being a long-term pasture, is quite a good shape, 2% carbon, 2.6 at this point. and still 1% below there, so that is quite a good figure for nutrient holding capacity and also for drainage. The phosphorus levels around the areas is sort of in that sort of maintenance sort of range, like it's at the pit here it's quite good, and others on average is around 20, so depending on production level, it's probably just needs a maintenance of phosphorus. But I guess the thing in this particular environment is the potassium levels in these layers are of a bit of a concern, and be interesting to after another lime application is to put on some potash. Obviously depends on the production level, how many animals per hectare we want to run, how fast we want to push, how much dry matter we want to grow. And I guess the other thing from the soil test is the surface copper is on a slightly lower rating, so be worth considering that either through a plant test later on and as a barrier to productivity. So acidity first, and then some of these other nutritional issues. As the acidity is fixed, these other nutrients become more available, and these topsoil areas will be a lot friendlier for plants, and also be able to grow a bit more. The other thing we can do in the field is a dispersion test with this sort of colour. The orange colour suggests it might be a little bit sodic, especially when you've got these sort of bleached layers of sitting above the clay. And we put a crumb of soil in, just as some distilled water or even rainwater, the topsoil in these layers are quite, and the dispersion just tells you whether there's sodium in the soil and whether it has an effect on root growth. So we've got the topsoil, that bleach layer, the top of the clay and the bottom of the clay, and we're looking for dispersion where it forms a cloud of fine particles, which we can see in the bottom of the clay has got this cloud of fine particles around the piece of soil we put in there, and the sodium pushes those particles apart, and so it gives us an idea, it provides us with the knowledge that this is sort of high in sodium, that clay, whereas the topsoil, top layers have no sodium. Down in this area is quite a bit more sodic and has dispersed. So that dispersion means when water hits it, it fills up all the pores, so reduces the amount of drainage. So the clay goes into the soil water solution as fine clay particles and can fill up the pores, and so reduce the amount of drainage. At that depth there's not a lot what we can do about it, but if it was up here, the application of gypsum is something you consider. But at that depth it's just a natural part of the soil profile. And I guess the other thing you'd look at in a soil test is whether it's a lot of salt in the system, but this soil is relatively well, considering those other issues, it's still relatively well drained, and salinity isn't an issue here, but it might be other parts of the landscape given that there's sodium in the system. due to this sodic nature and those pores blocking up, it does restrict root growth. So the roots are only a small amount in that 60 centimetres and not many below. So it is inhibited partly by the soil, but also by the nutrition in the topsoil. The plants aren't as vigorous as they could be due to the acidity and the temporary waterlogging. We can come up with a theoretical readily available water by calculating the amount of clay in each layer and then multiplying it by a factor like for a sandy loam might hold 1.3 millimetres per centimetre, whereas a heavy clay would be 1.48 millimetres. So you can work out a theoretical plant available water for the profile, and this one, because of its depth, is down to 0.8. It's sort of in that 106 millimetre. So once the soil is fully wet and then drained, it can hold 106 millimetres of moisture for the plants to use. So that's what we talk about, the plant available water. Obviously there still might be moisture in the clay, but the plants can't utilise it because it's not available to them. It's held tightly by the clay. But the plant available water is, we look at it, and it's a theoretical number derived from the clay in each layer and how much water it can hold and how much is available to the plant. And once the profile is full, say in September or August here, and it drains, the amount of water left is what's available to the plant. So that'll be topped up and drained throughout a year, but once it's full and drained, this profile could hold 106 millimetre. So it's got reasonably good water holding capacity. We're on the mid slope, mid to upper slope, and so theoretically it can hold a reasonable amount of moisture. Another in-paddock test you can do is looking at the amount of calcium carbonate in the system, and that can have an effect on nutrient availability. In this pit, the calcium carbonate is virtually nil, and people might see this white layer and think it might be calcium carbonate, and by putting a little drop of 0.1 hydrochloric acid on it, it doesn't fizz, so it's not limey. It's just the white colour of the bleached colour of the soil. So we have a scale with the amount of fizz it might have as to how much it might affect nutrient availability. Obviously the more fizz, it affects the amount of nutrients that the plant can get, just due to the pH and the chemistry of the soil.
Thank you very much to the landholders who allow us to use their land for this project. If you'd like to find out more about this project, please visit the BIG website at www.biggroup.org.au. This project was delivered by Adelaide and Mount Lofty Ranges Natural Resources Management Board with funding from the Australian Government through the National Landcare Program.